Hello again. Today we're going to do lesson 41, and this deals with functions. All right, so let's start off by defining a function. Write this down for me. For yourself, actually. Function is a relationship between two sets of numbers where for every input there is exactly one output. Okay, a relationship between two sets of numbers where for every input there is exactly one output. Okay, we'll come back to this. The relationship between feet and inches is a function. Write an equation that shows how to find the number of inches, n, output, if you know the number of feet, I, input. Then make a function table that shows the number of inches in 1, 2, 3, and 4 feet. Is the relationship linear? Is the relationship proportional? Okay, so let's start off here. There's my equation. Okay, for my input inches, or I'm sorry, feet, there are 12 inches in every foot. So my output will be the number of inches in I feet. Maybe this will make more sense to you when we make the function table here. Here's a function table. We got our inputs and our output. Inches, 1, 2, I'm sorry. Our input is feet. It's a little confusing. Let me let this all play out and then I'll discuss here. This relationship is both linear and proportional. Okay, so n equals 12 times I. That means the number of inches is equal to 12 times the number of feet because there's 12 inches in every foot. So when we use inputs of 1, 2, 3, and 4 feet, we get outputs of 12, 24, 36, and 48 inches. Okay, this is linear because as I increase inches by 1, feet by 1, the number of inches continues to grow by 12. That makes it linear. What makes it proportional is that whatever I can always multiply the input by the same thing to get the output. 1 times 12 is 12. 2 times 12 is 24. 3 times 12 is 36. 4 times 12 is 48. That's what makes it proportional. Okay. Yolanda played a new number game with Javier. She used this equation to generate her response to each number Javier said. Y equals x minus 2. Describe with words the rule that Yolanda uses, then make a function table that shows the numbers Yolanda says for 4 numbers Javier might say. We're going to use 0 for one of Javier's numbers and 3 more numbers of our choosing. Is this function linear and is it proportional? Okay. So let's look at 2 screens here at the same time. So let's describe it with words too. Yolanda will subtract 2 from the number that Javier says. Javier's number minus 2 is going to equal what Yolanda says. So Yolanda will subtract 2 from the number Javier says. Okay, next, we're going to make an input-output table. Javier's going to say 0. I'm going to make him say 1, 2, and just for fun, I'm going to make him say a negative number too. And here are the numbers that Yolanda will say. If Javier says 0, Yolanda will say 2 less, negative 2. Javier says 1, Yolanda will say 2 less, negative 1. Javier says 2, Yolanda will say 2 less, 0. Javier says negative 5, Yolanda will say 2 less, negative 7. Okay, and is this function linear? Yes, because as I go up, okay, by 1, Javier's or Yolanda's number will continue to go up by 1 as well. So as this goes up by the same amount, the number Yolanda says goes up by the same amount. And is it proportional? It actually is not proportional. Let me explain. 0 times -2 is, well, in other words, can I multiply numbers in this column by the same thing every time and get the number in this column? Well, 1 times -1 is -1. 2 times -1 is not 0. Does that make sense? One more time. 1 times -1 is -1. 2 times -1 is not 0. Okay? This would have to be -2 for this to be proportional. It is not proportional. We'll talk about that more in class if that's a little bit confusing to you. So the function is linear, but it's not proportional. This table shows the capacity in ounces of a given number of pint containers. Describe with words the rule of the function and write an equation that relates the pints P to ounces Z. Then find the number of ounces in 5 pints. Okay, first thing, describe with words. How about we just say there are 16 ounces in every pint? Then we're going to write an equation. So how about we say the number of ounces, Z, is equal to 16 times the number of pints. So there we've related pints to ounces. And now we're going to find out how many ounces are in 16 pints. Or I'm sorry, 5 pints. So we'll go 16 times 5 is 80 ounces. So there are 80 ounces in 5 pints. State whether the relationship between the numbers in this table is not a function. Okay, so if we go back to the original definition of function on slide 1 here, it says a relationship between two sets of numbers where for every input there's exactly one output. For every input there's exactly one output. So every time I put 0 in, I better get 0 out. Every time I put 1 in, I better get 1 out. But here I put 1 in, I don't get 1 out. That's what makes it not a function. It's because the input 1 has 2 outputs. It has more than one output. The input 1 should always give us the same output. But in this case, it gave us 2 different outputs. So I'll restate the definition here. Every input must have exactly one output. Okay, we got Yanos and Xena this time playing a numbers game. This graph shows all the possible pairs of numbers they could say following the rule of the game. Make a function table that lists 4 pairs of numbers they could say, and then describe the rule Yanos followed and write an equation for the rule. All right, so I'm going to plot some points here. And here's some numbers they might say. Xena might say -1, and Yanos would say 1. Xenos might say 0, and Yanos would say a 0. Xenos might say 1, Yanos would say -1. Xenos might say 2, and Yanos would say -2. So we're going to describe this rule. For any number that, I said Xenos, I'm sorry, I meant Xena, that Xena, I said it here too. For any number Xena says, Yanos will say the opposite. I'll fix that. Be a good question to ask you tomorrow, huh? Okay, moving on. Make up a number game Yanos and Xena could play. Describe the rule and write an equation for the rule. Make a function table that has 4 pairs of numbers they could say. Graph all possible pairs of numbers for the game you create. So, describe a rule. Make a function table for that rule with 4 pairs of numbers. And then graph all those possible pairs of numbers, meaning graph all those pairs and then draw a line through those pairs. I'm going to leave this for you guys. A little bit of homework within your lesson tonight. Describe a rule. Make a function table with 4 pairs of numbers, and then graph those 4 pairs and every other pair that Yanos and Xena could possibly state. I'll let you do that on your own. For right now, we're going to go to example G, and we're going to do one more together. For the function y equals 1/2 x plus 1, make a function table and use it to graph the equation. Okay, so y equals 1/2 x plus 1. Whatever x is, we're going to take half of it and then add 1. So I'm going to choose some numbers here to plug into my table. I'm going to use -2, 0, and 1. I'm sorry, 2. I'll tell you why here. Half of -2 is -1. -1 plus 1 is 0. Half of 0 is 0. 0 plus 1 is 1. And half of 2 is 1 plus 1 is 2. That's enough. Oh, we'll do one more here just for fun. Half of 6 is 3, and 3 plus 1 is 4. I'm going to plot all these points. 6, 4 is way over here. And then I'm going to draw a line through all these points. And this line represents all the pairs of numbers that work in this function, also known as an equation, but not all equations are functions. Okay, so that's all I've got for you today. We'll do some practice with it tomorrow. Have fun. Good night.